Alright, so in today's video, I'll be sharing with you all of the steps for creating this design. This was inspired by a reference that I found, which shows a molding design. And the cool thing about this is we start with a point and we move this around. So by moving that point in different directions, we're able to create a detailed molding that we can update using the sliders here. But what's most useful about this is that we can apply this to any other line segment. So let's say a polyline that is complex like this, we can set that as a curve, change the input, and see all of the details changed as you move the sliders here. So a lot of the steps that you'll see within the script are going to be very useful for other designs. So hopefully you're excited to learn a little bit more about parametric modeling. We can also set arc line segment. And some of the capabilities is if it changes the orientation of the molding, well, we can also rotate this right side up or to the inside, or even change the direction of where it happens on the inside or on the outside. So thank you very much for joining today's video. I hope you learned a few more tips and tricks here, and I hope you're excited to get into this design. And yeah, let's jump right into it. Alright, so before we start the tutorial, I'm going to be dragging in here the reference of what we'll be doing today. So today we'll be using this reference, which is a molding design, and what we'll be doing is creating this parametrically. So now that we have this and you see the idea of how this is laid out, I'm going to be referencing that. So I have it here on the side. I also attached it here so we can see it together. So let's start by creating the parametric point. So I'll go here to construct point. And the idea is that we're going to be moving the point around to create all of the forms that you see here. So we'll go to construct point, then route it through an empty point component. This way we can change that location if we want to. Now that we have the first point, we're going to be starting here at the bottom and then making our way all the way to the end here. So starting with this point, we're going to then move it. So this is going to be point 1. So I'm going to group this one, Control G. If you have a different color, you can change that and set it as a default. And then I like to group it, change the group name to 1. So this is going to be the first point. Then we're going to be moving it here by 30 plus 10. The cool thing about this is that we can always change the numbers. So we'll be referencing this for the numbers, but as you know, we can always change it. So let's take this number 1 point and move it in the X direction. By 40. Then we'll route it through this empty point component. So I'll just take this and copy it by tapping Alt. And when you move it, it lets you create a copy. So we'll make this one 2. Now that we have this second point, now we can move this up by 35. So once again, move this in the Y direction. So I'll change the vector. And here I'll change it to 35. So I'll keep this one hidden, and I'll actually be copying both the move and the point. So this is going to be point 3. Now we'll be taking that point and moving it back by 10. So I'll take this, I'll copy the X direction, Since we're moving it back, we're actually introducing a negative component to move it backwards. Now we'll change this to 10. So we can be a little bit more efficient by copying some of the sliders. We'll group this one and make this one 4. Now we have 2 radii, which means that we need to create the 50 by 70 and the 75 by 75. So let's move this point up by 70 using this dimension. So moving it up means in the y direction. So we can just copy this one. By 70. So we'll introduce number 4. And we'll make this 70. So it moves by 70, but this is going to be 0.5. Now that we have that point moved up, we're going to move it over again by 50 in the x direction. So I'll use this one because it has a positive x value. And we'll plug in the 5 into the move component. And this is going to be by 50. And this is going to be point number 6. Then we need to move that same point up and over to the right. So up by 75 and over by 75. So we can copy the y vector and the movement. And now we'll copy this will be 6, 7. And copy the x direction again. Making this one 75. And that's going to be 0.8. If I'm going a little bit quick here, just understand that I'm just doing the same steps over and over again to create the base points that are going to be creating the form. So now that we've made it all the way up to this location, let's move it over by 15 and up by 40. So x 15 and y by 40. So even though we already moved it to here, that's going to be the arc. So let's move it over by, like I said, 15 and 40. Let's go to the x direction. 15. That's the x direction. So we're doing this in the y direction. Okay, we've made it all the way up here. Now we're going to move it back, but instead of using a specific slider, we need to look at all of the sliders that create the overall size of this. So it's going to be 40 plus, or 40 minus this number plus this number, which is 50. So we need to add all of the x vectors so we can take this point and move it back. So going back to this one, we started with 10. No, we started with 40. Then we moved it back by 10. I'm going to be adding. So I'm do a plus sign. This brings an addition. Is going to be 40. Plus 10. Then if we move here, we can see all the vectors. So here we have plus 10. Then Actually, it's going to be minus 10. So here we'll go to a negative component. Then plus 50. Then plus. So we can go zoom in here, and you're going to see that you can actually add another input. So with this additional input, we can go to 75, then 15. Now we could add vectors, but we're just going to be adding the numbers and then introducing another vector for the X direction in the opposite way. So we'll go here to 15, plug this in. So we know that we have 1, 2, 3, 4, and 5 different vectors that made up that entire X size. And so we have 1, 2, 3, 4, and 5 of them, making it 170. And that's different to this because this is actually 30 plus 10, where we actually set 40 and then moved it back. So we have the overall size of it. So now here we have the Z vector or the X vector, and then the negative component to move it backwards. I'll bring this down here, and I'll hide the wire display because we're borrowing a lot of numbers from spots that are kind of far away, and that's going to make our script messy. You can always select the component and see where the inputs come from. But this will let us then take point 10 and create point 11 using this as the input and this as the vector. And let's say you mess up somewhere along the lines here, adding or subtracting, you're going to be able to see that it's not lining up, and therefore that's something that you could fix because you can visually see where the points moved. So now it's a matter of connecting the dots, but also here we have arcs that have to be created a specific way. So let's go here and make this last one, number 11. And let's connect all the points. So I'll be hiding the display preview. Some of these components that are not critical. The critical ones are going to be the points that we're going to be connecting. So starting with point 1, which is the first initial point, we're going to be creating a polyline. And so we'll start with point 1, move on to point 2, holding down shift, you'll see the plus sign, which lets you add more. Then we're going to go to point 3, which is going to be moving up. Then point 4. And we'll stop there. Why? Because we have an arc here, and then we have another arc here. So now that we see point 5, 6, and 7, we can start at number 8 here. And so let's copy that polyline component, and I'll hide the wire display. So we'll start with 8. And once again, hold down shift to add more inputs for 9, 10, 11, and then back to 1. So how are we going to connect these? So let's go back to those numbers, which are going to be starting at 4. So we're going to be creating the arcs. The arc starts here, ends here. So let's go to an arc component. And I'll be using arc seed. Now there's different ways that we can create an arc, But with ArcSeed, we have the start point, which is this one, 4, not 5, but 6 is the endpoint. And the direction is going to be this vector, which is the y direction. And it uses that vector of the y direction as the arc location. The other way of doing this is using a NURBS curve. You can start at point 4, go through point 5, and then point 6. Now notice that that's not a real arc, that's a NURBS curve arc, and we can change the degree for that. The other way is using a polyline between point 4, 5, and 6 again, and using a fillet. And then here, using a slider for rounding off the edge here. Now what happens here is that we need to make sure that this is one polyline and that the radius falls within what we want to do. Like I said, for this exercise, I'll be removing those. I just wanted to show you there's more than one way to do things here. We'll be using this. I think deleted the polyline. Okay. So now with this one, we're going to be doing the exact same thing with this one. So this is going to be 0.6, 7, and 8. So 6 and 8. Six is the start point, 8 is the end point. And the direction, rather than being the positive y, is going to be a negative y. And the start point actually has to be, let's see, start point, end point, and it's going to be the x direction. So negative x direction, not the y direction. So it's actually the positive x direction because it has to be this way. Now, the other way would be in the y direction. If we start here and end here, it could be in the negative y direction. So those are just some things to keep track of. Is if this is the first point and this is the last point, then the direction of where the arc is going to be located is going to be positive x. So now we can take all of these line segments and join them. So I'll go here to join curve. Holding down shift, I'm adding more than one. And I'll be hiding the input. So here we have one close planar curve. And so the way to test it is middle click and bake it. And so notice that now it's been created perfectly here. Now, so far we've just kept it static in the sense that we've inputted the numbers. Now let's move those around and change them. So let's say we wanted this to be 20 or 5. We wanted this to be 2. And let's decrease the numbers here and show you that you can decrease all of the numbers here and it will still work. The reason why is because when you're working in inches, you don't want it to be too large. But what's cool about this is that you can always change the inputs and create completely different outputs. So if we want the arc part to be larger, we can change this. We can also change this. And let's see if we can take these two arcs, join them independently. So this is an additional modification, making sure that it's one of them. So now it's one, and then fill the radius between those two. To create a smooth curve there. Now this is not necessary, but in some cases you want the form to be as smooth as possible, especially because the next step is going to be taking this and putting this on a curve to be able to turn this into a 3D object. So now we'll take this and we will reset all of this. So starting with first polyline, this one, then moving on to this one, and then moving on to this one. Oh, we're actually joining this. Join curves. Oh, actually no. This was the last one that was created back here. So now we're going to be using that one to join this one, and the first part. And if you'll see, sometimes it will say 2 separate curves. So we'll go to flatten input. Let's see if we can see how things are organized here. So I'm bringing in a panel. This one says 0, 0. How this is organized and how this one is organized. That's 0. So what we have to do is plug in and graft these two. We'll bring in a panel to see how things are organized now. So notice that here, the way that the sets are organized are going to be the same. So when we bring it and join it together, we don't have to use flatten. And the reason for that is because sometimes you want to apply this to more than one curve, and this will make sure that we can do that. So using graph tree on this one, we'll actually start with the first one first, this one, then this one, and then this one. One close planar curve. And we can hide the wire display on everything. So we don't have a messy script. All right, now let's take this form and put it onto a line segment and to extrude it. The first thing we're going to need here is going to be a reference plane. So we have point 1 where we can create the reference plane. We can also put it here at point 11, which is the last one. And so to be able to pick between those two, I will actually use the list item and use this as the input and this as the input to be able to have the ability to pick which one. So we'll go here to 1. And now we have between 1 and 0 that we can pick. So now with this, having the ability to pick it, I'll actually unflatten it because we may want to change that. And it still works without it. Okay, so now with this, having the ability to change it between 0 and 1, now this point is going to be where we put the reference plane of the XY plane because it was created here in the XY coordinate system. The reason for that is because we can now use this reference plane that we can change where we want it to start. And now we can move that to any location that has a reference plane so we can match them. So now that we have this, I'll hide the wire display on this. This is going to be the reference plane point. And sometimes if it's 0 and 1, you may not want a slider. And sometimes you could use a value list. And a value list is going to let you pick, so reference plane, it's going to be the name of it. 1, notice that it displays what you want, and it also has, it's referencing 1, 2, 3, and 4, and those are going to be what it equals. So we'll delete these because we don't need 4 inputs, we only need 2. And we'll use 0 and 1. So this is going to be 1 and 2. So this is going to be point 1 and 2. And now you can just switch using this drop-down list. So I think this is a little bit of a cleaner way to do that. It's also a personal preference thing. So now I'll hide this one. Now that we have the geometry ready, so we have the curves, I'll put this line segment through this curve component to keep it clean. And I'll put this XY plane through a plane component to also make sure that I know that this is going to be the plane output. I'll group this one and group this one. This is something that I will probably turn into a cluster. So using these inputs and these outputs, we can now create the next location, which is going to be where this is going to be put. For this next part, I'll be actually creating a parametric line segment. I'll go here to a line or an SDL line, starting at, we'll just copy this. Starting at the origin point 0, 0, 0, and then the direction is going to be in the Y direction or in the X direction. It doesn't really matter. This is just going to serve as the base geometry to put into. The length is going to be whatever length line segment. Now that we've created this line segment, now we need to create a plane that is the reference that we want to put it onto. So what I'll do is I'll take all of this, middle click, and disable. This way, this is not being computed at all. We're just working on this line segment. So this is under the category of like isolating your geometry to work on something else, because we've already set the stage here, creating the molding that we're going to be placing onto the reference plane. So now that we have this line segment, we're going to be creating a perpendicular frame. A perpendicular frame is a construction plane based off of a curve. And the parameter is going to be at 0 because we want that plane to be at the beginning of the line. So now let's go here to a slider of 0. Notice that now we have a construction plane, X, Y, that we can use to place the object onto. So I'm bringing it over here because the next component is going to be orient 3D. And with this component, it's very useful because it can take an object with a reference plane and locate it exactly at a target reference plane. So I'll be using another plane component here just to be consistent. And this is going to be the target. So this is where we want it to go. The source is going to be this plane, and the object is going to be this line segment. So now, to make sure that everything works, let's enable and let's show everything here. Notice that we've placed it. Let's hide all of the inputs here. So we placed it right at that location, starting where this reference plane is and locating it right here. Now there's a few things that we may want to change, like we can change this point location. We may want to rotate this around. So this is where we'll take this reference plane and this object, and we can rotate this object relative to this reference plane. So now the angle is going to be in degrees. And I'll show you a slider here. So we'll go from 0 less than 360. And one of the things I learned and that I like doing is going to edit snapping. And now we can make it snap at specific numbers. So at 90, at 180, and at 270. So you'll see these little dots. Now we can rotate them. So this is useful because depending on where you want it to be located, we can change the rotation. We can change where it starts. So let's say this is going to be the base molding or the crown molding. You can use a base curve or the top curve. Now where this goes on either side, that's where we can use a mirror command. So this is going to be the last thing that we'll do before we actually extrude it. We have this, which is a perpendicular frame. But there's also something called a horizontal frame. And this one is just as useful as a perpendicular frame because at that location of 0, we want to take this plane and rotate it 90 degrees. So rotating the perpendicular frame relative to the horizontal frame by 90 degrees, giving us all of the reference planes that we're going to need. Now with this one, with this geometry, by default, we have 4.5 pi, which is half, which is what we need. We can also change that to degrees and then do 90. But since by default it's working, we'll now bring in the next component, which is a mirror. Now, the mirror component, it's pretty straightforward. We're going to be using this plane input. And now we can mirror this object to the other side. So now what we'll be doing is similar to what we did with the points where we can pick 2 of the points. We're going to copy that over and use these two. This is one input, this is another input, and show it here and hide both of the outputs here. Because now between 1 and 2, we can do here not reference plane, but mirror object, or mirror, just mirror should be fine. So 2 is the second one, 1 is the original one. And so this is a really clean way that we can now, through this output, which is a curve, take the input of that line segment. And since we want to be able to change that, I'll double click here. The reason for that is there's 2 different outputs, but I also like to route it through an empty curve component so we can change that location as well. Now this curve and this one is going to be the line segment that we use to sweep this line segment. So now I'll go here to this rail, which is going to be the line segment. The sections are going to be this section. And then, since it's an open brep, I'll go here to a close or cap pulls, which will put the end bits into the form here. Hopefully I didn't lose some of you guys in some of these portions. I went kind of quick, but the cool thing is you can always go back and see what I did, or you can even download it from the website to see how all these things plug in. Trying to keep things as organized as possible here, showing you all of the different steps. And then here, I'll route it through a geometry component. Group this because this would be the end location. And then, just as an additional thing to be able to see the form a little bit better, because right now it's transparent red, we can go to custom preview and change the color using a color swatch, since it's by default pink. This way we can see, depending on what color we want it to be. Like sometimes I'll go here to like 25. Go to 80. Let's move some of the sliders here. So I think some of these forms that get created when we move things around is really the power of parametric design, because obviously we know that we can create some of those forms without parametric tools, but having the ability to look at your form being swept and then seeing the changes here, it really allows you to see all of the options of the designs that you can create using this just one script, right? Now this is going to be a consistent one, so I do tend to internalize data for both of these. And internalize data means that it will just set that number inside of the parameter or inside of the component. So you don't have to use that slider. Why? Because if I share it with someone, they might move that slider and it might mess up the entire script when those are consistent numbers that don't need to change. So here, reference plane. the location could be at the top or at the bottom. And then here, I don't want it to be done on the other side. So now let's look at a different curve input, see if that works here. So we routed everything through this point or this line component. Now let's go here to a NURBS curve. We'll bring in another curve component, set it in here. So set one curve and plug this in. Now sometimes it will switch the orientation of your script. So this is where we can always go back here and in some cases change this back and then be able to change this. Let's say if I want it to be on the other side. Now I think there's going to be some limitations on whether this works on something that goes up and down like this. That's because the reference planes are horizontal and vertical. And so, like I said, there are going to be some limitations to this. This is going to work on line segments, but let's see. And I think this will also work here using rectangles. Now here, it's having some issues with that. I think it has to do with the way this is oriented. So if we just rotate this back down to 270, I think it was working when we do it up. $90. Or sometimes it has to do with flipping the direction here. You can flip the curve direction. But there are limitations like that where you may not be able to do it on a closed curve. It has to be done on an open single curve. But you can set it on something like this. So it can turn a corner, it just can't close it off. So if I go here to here and then right up to it, it will work. So in some cases, you may want to do something like this, but all you need to do is make sure that you trim off a little bit here and then you need to close that off. So like I said, this is not a solution for everything, but it can help you save a lot of time and help you get to a point where you can create all of these with just a single line segment. And that's actually something that we can parametrically do here, which is take that line segment and take that last, whatever line segment, if it's a multi-line segment, take the last bit, cut it in half, and then take off a little bit. So hopefully you learned a few more tricks here about how to use parametric tools to create molding designs like this. A lot of the tricks that you'll see here are going to be really useful for other things like the Orient 3D. This is going to be one that I'll be going over more on in the future because this one is going to be really useful for many different things. I also started a new segment on my website called Utility Scripts, and that's going to be for scripts that are not full designs, but they are for utility things like creating custom line segments and other things that don't involve full design scripts. So thank you very much for being here. Thank you for the support. Thank you for watching the videos, and I hope to see you in the next video.
Generate, iterate.